Hello my students, today we have paper 6 or unit 6, October 2023 for Edexcel board. You know it's an alternative to practical skills chemistry 2. The calculator is allowed in this test, and you know also we have 50 marks for this paper, and then it is converted out of 60. The first question is a series of tests is carried out on a violet colored solid A, which contains 2 cations and 1 anion. Some solid calcium oxide is added to a spatula measure of A in a test tube and the mixture heated gently. A pungent smell gas is given off, which turns damp red litmus paper to blue. Give the name, the formula of the gas produced in this test. So where it is a pungent smell gas and converted damp red litmus paper to blue, so it will be ammonia gas. So ammonia gas is produced in this reaction, and then he will give the formula of the cation in A that's shown by this test. He added the calcium oxide, which is a base, is added to spatula measure of A in a test tube and heated the mixture gently. What is formed is ammonia, and the cation is ammonium. So you can write the formula, which is NH3 gas, or its name or formula. It is ammonia gas. Give the formula of the cation Na. Here he focused on the formula, and you should write an H4 positive 1. So that's the formula of the ion which is given by this test. The next idea is the alkaline solution. The alkaline solutions, are added drop by drop to the separate sample of an aqueous solution of A until there is no further reaction. With dilute sodium hydroxide, a green precipitate forms which dissolves in excess sodium hydroxide, giving a green solution. With dilute aqueous ammonia, green precipitate forms which dissolves in excess ammonia, giving a violet solution. State the type of the reaction that occurs when the precipitate dissolves. First of all, the sodium hydroxide was added to remove or deprotonate. This is to remove hydrogen ion solution, or what is called deprotonate the solution. With excess ammonia, what is given, it's what is known from our studying for the theory, it is ligand exchange reaction. Okay. Next one. Give the formula of the cation Na, shown by the test in B. So here we are talking about chromium positive 3. Why? Because the violet color was given in the second test. Now, an aqueous solution of A is acidified with dilute hydrochloric acid, and a few drops of barium chloride solution are added. A white precipitate forms. gives the formula of the anion. Since barium was added and the white precipitate was formed, so this means that ammonia is given, and he's asking you about the formula, so it is SO4 negative 2. State the reason for adding the dilute hydrochloric acid. Here the hydrochloric acid will react with any precipitate that is formed, or it will react with carbonate, okay, or to eliminate other ion, give a precipitate with barium. So to eliminate another or other ion or anion like CO3, for example, okay, that, or sulfate, for example, that can form precipitate with barium positive 2 ion or barium chloride. Okay, now suggest the formula for the compound A using your answer to A and B. That's very easy because we have a chromium positive 3 and we have also ammonium, so it is ammonium chromium SO4 by 2. That's the formula. Like that, we finish the first question from this paper. Now you can go further for question 2. Compounds B and C are isomers with the molecular formula C3H4O3. Compound B is a colorless liquid with the structure shown. Name the functional groups present in B. It's very easy. We have ketone and we have carboxylic acid. So carboxylic acids and ketone. Okay, now next ideas. A series of tests is carried out on B. Complete the observation boxes. 2 cubic centimeter of aqueous sodium hydrogen carbonate in AHCO3 is added to the test tube containing a small quantity. Since we have acid, so bubbles of gas or effervescence of gases, it will be produced because there is an acid with the carbonate. The carbon dioxide was produced. A few drops of B are added to cubic centimeter acidified potassium dichromate solution. The mixture is placed in warm water bath. No color change because there are ketone there. Okay, since we have ketone and we have carboxylic acid, so there is no change. So it will be, or it starts by orange color, orange solution, and it stays orange solution. Now, for next one, few drops of B are added to 2 cubic centimeter of solution of 2,4-dinitrophenyl hydrazine, which is a Brady's reagent. Now, this test will show the yellow-orange precipitate with ketone, and that's the point. So we have yellow precipitate for this reaction, since identification for a few drops of B are added to Fehling solution. The mixture is placed in warm water, and here you will see Fehling solution. It will stay blue, one, because there is no oxidation. Closed solution, and here it stays without change because it will not oxidize any of the ketone or the carboxylic acid. That's a test for aldehyde. Few drops of B are added to cubic centimeter solution of iodine dissolved in the sodium hydroxide solution. The mixture is placed in the warm water bath. Now this is a test for the methyl group. So pale yellow precipitate will be formed here. Pale yellow precipitate forms since the methyl group presents beside the O group. And what is next? Here, compound C, C3H4O3 is also colorless liquid. C is non-cyclic and does not contain carbon-carbon double bond, has a significantly lower boiling temperature than B, does not react with, so there is no hydrogen bond, does not react with PCl5, so it is not an alcohol, reacts with Tollin's reagent to produce silver mirror. Draw the displayed formula for the structure C3H4O3. So this will identify the presence of aldehyde and also something which is not cyclic, and there is no alcohol, so it will be like the following structure. One of the possible answers is like that. Okay, maybe it can be 1. Look, it's 1. Then it will be sketoneous. And here we have C double bond O and H. So that's one of the possible structures. There are other possibilities, but here you can check. We have 3 carbons, 3 and 1 for hydrogen, and we have 3 O's. And also we have 3 O's. He's asking you C3H4O8. That's one of the possible structures, or you can do aldehyde and then O in the middle and CH2. More than one structure are possible for this answer. Now, the next question. This question is about the ethane dioic acid, CaO2, also known as oxalic acid. The traces of ethane dioic acids are found in many foods, including Spanish fruits, nuts, and seeds. A group of students carried out an experiment to determine the percentage by mass of ethane dioic acid in the rapa leaves. Okay, the first stage of the experiment was extraction of the ethane dioic acid. Okay, now 319 grams of rapa leaves was chopped up and placed into the large beaker of distilled water. the mixture. So he gave you the mass of the leaves, and the mixture was boiled gently for 15 minutes and then filtered. The solution was transferred to the volumetric flask, and the volume made up to 1,000 cubic centimeter or 1 decimeter cubed. The distilled water and mixed it roughly, and the solution was labeled R. One student suggested that the hexane should be used as a solvent rather than water. Explain why the water is used as a solvent and not hexane. Now, if you return back, this question is about the ethane dioic acid. So, ethane dioic acid, it's a carboxylic acid, and you know, if there is a carboxylic acid, we are talking about the solubility of the acid in water is very soluble because it can form a hydrogen bond, because the structure of ethane dioic acid is like that. So the answer is, it is the ethane. Okay, here we have talking about the ethane dioic acid. So he's asking you about the ethane dioic acid. So ethane dioic acid is highly soluble in water. That's why water is used, since it can do or form hydrogen bonding and between the water and ethane dioic acid, and this will make it more or highly soluble in water. Then the second stage of the experiment was the titration of the ethane dioic acid solution R. 25 cubic centimeter of R were placed in the conical flask, titrated with either aqueous sodium hydroxide or cerium sulfate. The equations for these reactions are blah blah blah, as you can see, and C is how you have yellow color, and Ca positive 3 are colorless. For each of these, titration described how the endpoint can be detected, stating the color change in each case. Now for the first titration, as you can see, it is acid-base titration, so it will require an indicator, and the endpoint will change from the colorless to pink, while for the second one, the cerium titration, it's self-indicating, and the endpoint, it's changed from, will form a colorless to yellow. Why? Because you will add excess amount. It looks like the manganate. So let me explain that again. Here we have alkali, we have acid. So phenolphthalein is the suitable indicator. And here, because this one is yellow, it's self-indicator, and this one is colorless. So the endpoint was when you add excess 1 drop of this, so it will goes from colorless to yellow. Okay, so the first reaction for sodium hydroxide and acid, it will be phenolphthalein indicator. In the second, no need for indicator, since it's self-indicator. Okay, self-indicating. Okay, and the color is from colorless to yellow, and the first one is from color. It's from colorless to pink. Okay. Okay, the next one. Some of students decided to titrate 25 cubic centimeter portions of solution R with 0.04 mole cubic decimeter of aqueous sodium hydroxide. The mean titer was 20.6. Calculate the percentage pi mass of ethane dioic acid in the sample of the leaves. Gives your answer to appropriate number of significant figures, and he gave you the molar mass is 90 grams per mole. Here we have 5 marks. So you shall write, first of all, you shall find the volume or the moles of the mean titer. As you can see, the moles of sodium hydroxide, so moles of NaOH first, that equals 25, it's a 20.6 over 1000 times the concentration, which is 0.04, and this will give you answer of 8.24 times 10 to the power negative 4 moles. Then that's in the portion of 25. And the next idea is the ratio between the acid and the sodium hydroxide is 2:1. So the moles of the acid, or COOH by 2, this one over 2, which is 8.4 times 10 to the power negative 4 divided by 2, and this will give us 4.12 times 10 to the power negative 4 moles. Then that's what we have in the 25 portions. Then we will find its mass, or it is times, that's the number of moles. Then he is asking you to find how many grams are there. So this is, okay, let us return, that's the moles of this. Where's the volume? Okay, here this is, again, that's 0.25. Okay, that's in 0.25. If you return back to the question, okay, where's the question? Here 25, and there is 25 cubic centimeter portions, and we calculate. Okay, so now we can continue by finding 4. So it is 4.22 424 moles in 1000. So it equals times 4, yes, So if this is 4.12, okay, let me see. So the moles in 1,000, okay, we have a 20 cubic centimeters, so 25. So 25 times 40. So the answer is 8.24 times 10 to the power negative 4 times 40 to find it in 1,000. So the answer is 1.648 times 10 to the power negative 2 moles. You know the molar mass is 90, so the mass is equals this one, the 1.648 times 10 to the power negative 2 times 90, and the answer is 1.4832 grams. And then the percentage by mass equals the 1.4832 over the given mass in the question, which is 319. If you return back, you will find that the original mass is what is that? Yeah, it's there. So the mass is 319. That's why we use that. So to complete the answer, it is times 100%. And the final answer is 0.46% of this in our question. That's a percentage. Now, for next question, ethane dioic acid is used in many laboratories. It's usually supplied as hydrated crystals and dissolves in distilled water to make a solution. A technician makes 500 cubic centimeter of 0.5 mole ethane dioxide solution by dissolving 31.5 grams of hydrated ethanoic acid and making the volume up to 500 cubic centimeter. Calculate the value of X in the formula of hydrated ethane dioic acid. First of all, you can find the number of moles for the volume. Okay, it's very easy. Now to find the number of moles, he gave you the volume, and this is the concentration. So the moles are 500 over 1,000 times 0.5. So this equals how much? It is 0.25 moles. So the same number of moles for the hydrated salt was present. Now to find the molar mass of COOH by 2 dot XH2O, the molar mass equals the 0.25 over the 0.25, or the mass. Look, the number of moles equals the mass over molar mass. So the molar mass equals the mass over the number of moles. So M equals the mass over number of moles. So the mass is 31.5 over 0.25, which will give us 126. And this one equals 90 grams per mole, this part. So now the molar mass equals 126 minus 90. This will give us 36. This is the mass of water. Now you know the molar mass of water is 18. So this will give you 36 over 18. This will give us water 2, so x equals 2. We are in question 4. This question is about the nitration of methyl benzoate. The equation for the reaction is shown. As you can see, this is the methyl benzoate. It goes to the 3-nitromethyl benzoate. Now, the procedure are weigh between 1.9 grams and 2.1 grams methyl benzoate in 50 cubic centimeter of conical flask. Slowly add 5 cubic centimeter of concentrated sulfuric acid to the methyl benzoate with swirling the and place the flask in the ice water bath to cool down. Place 2 centimeter cubed of concentrated nitric acid into a test tube. Cool the nitric acid down, and by immersing the test tube in an ice water bath before slowly adding 2 cubic centimeter of concentrated sulfuric acid, allow the nitrating mixture to cool down using the teat pipette. Add nitrating mixture very slowly to the conical flask, ensuring the temperature does not exceed, or here we can use a dropper, do not exceed 7 Celsius. Allow the flask to stand at room temperature for about 15 minutes and then pour the contents to the beaker containing some crushed ice and pure methyl 3-nitrobenzoate will form. Recrystallize the methyl 3-nitro using methanol as a solvent. Weigh the dry crystals and determine their melting temperature. A bottle of concentrated nitric acid, that's the first question. Nitric acid has 2 hazard warning signs, as you can see. The first sign is corrosive and the second is oxidizing agent. So corrosive and oxidizing agent, okay, or reagent. Now, the next one, give the precaution to reduce the risk when using the concentrated nitric acid. Safety goggles was used and the laboratory code, so you can wear the gloves. Same why the nitrating mixture is added slowly in step 4. Okay, for step 4, if we return back, we will see that for step 4, what we have for step 4, he's asking you to using the T-pipette nitrating mixture curve, okay, very slowly to the conical flask, and this is because the reaction is highly exothermic, and this is because the reaction is highly exothermic, and the other reaction or more than one nitration will take place, because here you want to nitrate the mixture. So the answer is the reaction is why the nitrating mixture. Now the reaction is highly exothermic. That's the first point. It produces energy at higher temperature, more nitration, the nitrations takes place. Okay. Now, during the crystallization in step 6, the methyl 3-nitrobenzoate is dissolved in minimum volume of methanol and the hot mixture filtered. The filtrate is cooled and the resulting crystals filtered and rinsed with the ice-cold methanol. State why the methanol is a suitable solvent for use in the crystallization of methyl 3-nitrobenzoate. As you can see, it's solid, which is used in a solvent. So here we shall think about the solubility. So at high temperature, the methyl 3-nitrobenzoate state why the methanol is a suitable solvent for use the recrystallization of methyl 3-nitrobenzoate. Yeah, because this one is soluble in methanol at high temperature. Okay. Say the purpose of each of the filtration during the crystallization of methyl 3-nitrobenzoate. The first one is to remove insoluble impurities, and the second one is to remove the soluble impurities. So the first one, it's in called to remove insoluble impurities. That's the first one, impurities. And the second one, that's the first, that's the second, to remove the soluble impurities, because what is needed is the residue, not the precipitate. Okay. Now, give the purpose of rinsing the crystals, stating why the methanol is in ice. Okay, the rinsing is to remove the solubility of substance, or to remove the soluble substance. First is to wash off the soluble impurities and to prevent the crystals that we need to. So, to remove the insoluble impurities, the filtration used, and it is in ice cold, to prevent the dissolving of wanted crystals. Okay. Now, 1.95 grams of methyl benzoate reacted with an excess nitric acid to form 1.51 grams of methyl 3-nitrobenzoate. The molar mass of both are given. Calculate the percentage yield. It's a normal question, and you will see that he's asking a lot about this, like in paper or unit 3 about this. Now, first of all, you can find the moles. So moles of nitrobenzoate, of methyl benzoate. So moles of nitrobenzoate. That's how much? It is 1.95 over 136. That's equals 0.014338, and then the moles of, they are the same, times the mass of 3-nitrobenzoate equals 0.014338 times 181. This will give us how much? It is 2.5952, and since he gave us the mass, so we will divide 151 over 2.5952. This is times 100%. This will give us 58.184%. And then he's asking you, give one reason possible or possible reason why the yield more than nitration maybe takes place, more than nitration, that's one, or there is a side product, or some was left on the filter paper when you are doing the crystallization. The next question is question 5. A group of students carried out a series of experiments to investigate the kinetic of the reaction between hydrogen peroxide and iodine ions in acidic conditions. The equation for the reaction is shown, and that's the procedure. First, measure 10 cubic centimeter aqueous sodium thiosulfate solution to conical flask. Measure 5 cubic centimeter of potassium iodide solution and 5 cubic centimeter of dilute sulfuric acid, and add these to the mixture in conical flask. From step 1, measure 5 cubic centimeter of aqueous hydrogen peroxide solution into a test tube. Add the hydrogen peroxide, record the time when the solution blue black within the starch and iodine. Repeat the experiment, varying the volumes, and so on. Explain the purpose of adding the sodium thiosulfate in step 1. So this will react with iodine, and it can be measure the iodine which we can measure the iodine which produced. That's the test of the result. As you can see, the starch is constant, sodium thiosulfate is constant, and sulfuric acid, what is changed is potassium iodide and this. Then he's asking you to plot the graph, and we did that. So the graph is, this one. So you can, sir, those are the values, and we did them, and you can see that it's linear relationship between the volume for potassium over the cubic centimeter and within 1T. And here he is asking you of potassium iodide volume within 1 over T. That's what we did. We put the volume on x-axis, and this is the points must be plotted like that, and you will see that the curve is linear. Now, deduce the order of the reaction with respect to iodide ion. I told you, since the linear curve, so it is first order. Give reason why the concentration of potassium iodide solution is significantly lower than that of the hydrogen peroxide. Okay, hydrogen peroxide solution and the sulfuric acid. This is related with the order of the reaction. Okay. When you want to study the effect of changing the concentration of the other, you shall make the others in excess. So to study, this will make the rate change by give the reason why the concentration of potassium iodide solution is the rate changed by Ki concentration and not the other. So if you want to study the effect of increasing the concentration of one of the reagents, you shall keep the other excess. That's why the reagents are used in excess when you want to study the effect of one concentration or the concentration of one reagent to another. That's everything in this paper. Thank you for good listening. Thank you very much. That's me, Bishr Samhan, on MetaStars platform.